All right. Well, got the computer working again. Sorry for all the glitches. I have no idea what happened, but Zoom did cut out in the middle of the last video, so I had to make this kind of into a two-parter. Not my intent. Um, I guess I did want to talk a little bit about the idea of a mixed number. So not 100% sure where the last video even ended, so I'm just going to pick it up and go from here. So you'll notice here we have 3/5 plus the 4/5, and we get 7/5. And really, if you picture this as being linked to 7 divided by 5, we get back exactly what we've seen in the past, namely this. The division algorithm says 7 is equal to 5 times 1 plus 2. So we have our dividend, our divisor, our quotient, and our remainder. And in the past, so again, if we divided both sides by 5, this is what it would look like. We would end up with 7 over 5 equals 5 times 1 over 5 plus 2 over 5, which becomes, because these in the first part get flopped, thankfully, we get 1 plus 2/5. And oftentimes we write this without the addition sign. We call it 1 and 2/5. We say the word and. Definitely does create issues for students in the kind of along the way. And the reason is if we write AB with no symbol between them, AB is A times B. Okay, so this is actually equal to A times B. What we have here is 1 and 2/5, but nothing in between them. This translates to 1 plus 2/5. So you're almost better writing it as 1 plus 2/5 or keeping it as an improper fraction so that you don't have that issue. And later, when we put the negative in front, if I want negative 1 and 2/5, there's actually, this represents negative 1 plus 2/5 like this. So there's actually an implied subtraction between them if we were to write it properly. So again, having no symbol between them does create some issues and just something to be aware of as you head into your own classroom. So definition of addition, if they have like denominators, is all you do is pretend that the type, which is your denominator, is just constant and then add the numerators. Okay, so not a huge difference. Again, many of you might feel pretty comfortable with this as it is. All right, so now here we go. How to add the rational numbers, 2/3 and 1/4. Now they've written them here as a beautiful circle, which again would be very challenging to draw. But the concept remains the same. If I don't have the same operator in terms of object, I should say, object, not operator. If I'd done the same object, these are thirds, these are quarters, they're not the same sized pieces. So what I could do is fluff them and we could make them into something. So 2/3 will still remain 2/3, but I could write it in many ways. I could write it as 4/6. I could write it as 6/9. I could write it as 8/12. I could write it as 10/15, right? Equals. So I could write it in so many different ways. I could do the same thing for 1/4. What I want you to see as I'm doing this is 2/8. It becomes 3/12. It becomes 4/16, and so on. I want you to notice that FLOF, the idea of the fundamental law of fractions, is creating multiples. Look at the denominators. The denominators turn out to be multiples of 4. And up here, these denominators turn out to be multiples of 3. So what we're really looking for is, can we find some common multiples? And the answer is always yes. And that's why we have the least common multiple. But you could also find the smallest one. and that would be the LCM. So before you really get going, you could say, what is the LCM of 3 and 4? They are relatively prime, so it really is just 3 times 4, and that gives you 12. And we can even see that here. So rewriting it and saying, I'm struggling to do this one without a plan, so I fluff the fractions, and 2 over 3 becomes 8 over 12, 1 over 3, 1 over 4 becomes 3 over 12, and now we have turned this into a problem where the denominators are the same, and we know we can just add them together numerator wise to get the final result. So that's the idea of fraction addition, and truly fraction subtraction, because fraction addition and subtraction are tied together. So create something that is equivalently sized pieces, equal sized, and you're ready to go. Oh, and I should say you could have used anything else. So just because you have 2/3 and 1/4, and 12 does work, you could have done 24. So multiply, floff this one by 8, floff this one by 6, and you've got 16 over 24 plus 6 over 24, which gives you 22 over 24. That answer is exactly the same as the 11 over 12 that we got by doing it step by step and using the LCM. Any common denominator will work. It doesn't have to be the least common. The least common tends to be the easiest and the quickest. So since any common denominator will work, we can generalize to, how do I do these? With any denominator, A over C, oops, I think they said B, A over B plus C over D. You just floff them. So this one has a D and this one has a B, and your end result becomes AD plus BC, the whole thing divided by B times D. Now, again, be careful. This does not have to be the least common multiple. So you might be able to do it with smaller numbers, but that is guaranteed this will always work. So there's our definition of how we would find it if they're not like numbers. Okay. So here, see 15 and 21, they have a common multiple, or they have a common divisor as well, 3. So common multiples, you could just do 15 times 21, but you could make it smaller than that, which might be significantly easier for you in some cases. That would be what I would recommend. So same thing here with 4, 5, and the 6. Again, if you just multiply them all together, you're okay, but you could go a little bit smaller than that. Okay, and don't worry, when you have things that are variables, don't try to find, we don't know what number is going to be in there, so it's okay to treat it just as if that is relatively prime, because there's nothing that is in common. All right, so here's the idea of mixed numbers. Now, again, there is a description in the book that shows you how to think about them. The biggest idea, I guess I would say, is understanding that if you link it to division, it's going to be a little bit easier because we already have the division concepts. But it's not ideal notation. The plus sign being removed does make it look like multiplication. A negative in front might make someone think that it's a -4 plus 3/4 because it was really a plus sign between them. But -4 plus 3/4 is not the same as -4 minus 3/4. And again, this is a little bit of a concept issue. So mixed numbers, if you do continue on in other math classes, or if your students do, we tend not to use mixed numbers. We use improper fractions. And improper fractions do, if you look at it, at -3 and 2/5, that again, do you mean -3 and then I add 2/5? And in this case, no, the opposite applies to the entire quantity, and the parentheses just aren't there to illustrate that. So it's easier in a sense to write this as -17 over 5, because then you can't be confused with what it is. You know exactly where it would be on a number line. Okay. Let's see here. Yeah, so linking this back to division, if you're doing 39 fifths, think of how many times does 5 go in there? 7 whole times and a remainder of 4. It's the exact same concept. Um, yeah, there's a section here on adding mixed numbers, and I should say that the way that I was shown was to just turn them back into improper and then go from there. I think it's actually quite a bit easier than that. Um, if you're okay with me kind of showing the idea here, if I was to add these numbers, okay, the old traditional way would be to multiply and turn this into improper, then find a common denominator, then add them, and then simplify back. So if you do that, that becomes 69, 70, 70. That becomes 71 thirds, 120, 152. That's 155 quarters here. Now, again, uh, now I have to find that fundamental law of fractions. So hit the times 4, hit the times 3 here. Look at how big these numbers are getting, right? Yeah, this becomes 12, but that's 3 times 155. So that's 454. Oh my goodness, 465. This is a 12 now, 284. I mean, this is just, these numbers are huge, and I'd add them all together to get twelfths. So think about the process that that would take. Option 2 is to almost treat these, because they are being added, as why don't I just add the fraction parts together first? And I can fluff those very quickly to make 9 twelfths and 8 twelfths. And when I add them, I get 17 twelfths. I can add these numbers together, get 50 and 61, and then remind myself that this is improper. So I need to swing something over. And guess what? You could imagine this like it's base 12. If you had 17 in base 12, you'd regroup one of your 12s over and leave you with 5 12s, but you'd bring one group over and you'd have this number. And it's so much quicker to think of addition, subtraction, multiplication, division, these as like whole number pieces together whenever possible, so that you don't have to stick with these massive, massive numbers. Okay. Let's see here, the additive inverse property. So what are the properties? Closure, commutative, associative, identity, and additive inverse. Well, the additive inverse property of rational numbers still holds. Any number that you add to another number and get 0 is an additive inverse. And just to highlight it, I know I've said it in other videos, but the piece that's important here is it is unique. There is a unique rational number. So if I had 2/3, what would I add to get 0? And you could say, oh, that's -2/3. Perfect. Okay. So that's the idea with the additive inverse property. Okay, let's see here, adding mixed numbers. There we go. So again, with small numbers, you'll notice sometimes even the textbook for the students would kind of keep the integer parts whole, keep the fractional pieces together and go from there. I think the subtraction is probably, yeah, the subtraction is probably the more complicated one there. So maybe I'll do an example of the subtraction with mixed numbers. Let's see here, find the additive inverse. Typically pretty quick, right? Because all you have to do is find the number you add to get back to 0. And this one is the addition property of equality. Again, if you have two equal numbers, you add the same thing to both sides, they stay equal. And again, and here we move into subtraction of rational numbers, which is good. You can still do the number line. And again, if they have the same denominator, it's quick. If they do not have the same denominator, then we need to make them have the same denominator. This is very similar. You'll notice some of the theorems look exactly the same. If I subtract two rational numbers, that's the same as adding the opposite, or the additive inverse. And the definition of subtraction in terms of addition is one fraction minus another fraction is the unique fraction, so that I can add and get back to what I started with. So nothing really shocking there. And lastly, This is very similar to addition. You might recognize it. I floff them both up, and then I just find the difference in the numerators. Okay. So when you are trying some on your own, if you see something like this, 5/8 minus 1/4, you can just fluff it so that you get a common denominator. And once you do, you can just simply subtract the numerators. Now, if you want to check yourself out, you can say, okay, if I want to check myself, it would be 3/8 plus 1/4. That has to get me to 5/8. And that's the same thing as 3/8 plus 2/8 by floffing, and it gets me 5/8 at the end of the day, so it checks out. All right, let's do one with these mixed numbers. So this is kind of a fun activity because it links back to what you did with place value. So 5 1/3 take away 2 3/4. And again, take a moment with the fractions and floff the fractional pieces to get a common denominator. So now I have 4/12. This down here is 9/12. So I want you to picture this. You have 4/12. You want to take away 9/12. You could say, I don't have enough 12ths. So what do? We don't borrow, but we could regroup. And we could say, I'm going to take 1 from here, and I'm going to trade it in for 12/12, because 1 is equal to 12/12. So I took one of these, think of them as poker chips, grab a poker chip, trade it in for 12 pieces. And so instead of 4/12, you now have 16/12 because you regrouped it. And then you can do 16 minus 9 and get 7/12. That's pretty quick. And 4 minus 2 becomes 2. And your answer is 2. And that looks horribly written. I'll rewrite it. 2 7/12. That is how you can do it with mixed numbers very quickly without having to result in improper fractions. Right. Let's see here. Yep, find common denominators. You'll notice here they do show the how to do it with regrouping. That's the one I just showed. But they also show a way where you turn it back into improper fractions. And again, that to me, your numbers are going to get bigger. In this case, they use 3, 4, 5, and 2. So they're pretty small numbers, but if it was 21 and these were 13ths, you're going to be in a nightmare world of arithmetic. So I recommend the first method whenever possible, and I think it's a good way to get there quickly. Now, the last piece they talk about is estimating. So in the grade 5 standards, they do talk about using benchmark fractions and the idea of number sense. So benchmark fractions are kind of convenient fractions. Probably the most common are 0, 1/2, and 1. Those are benchmark fractions, but you could also have quarters. So 1/4, 2/4, which would be 1/2, and 3/4. So those are covered, and then thirds. Those are pretty much the kind of the convenient ones. So when you are trying to, let's say, add these together and you want to estimate, right? You could say, well, let's see here. Let me do a little adjustment, and we'll just do all the front end pieces first. So the 1, the 3, the 5, and 0, 5, 6, 7, 8, 9. So that's 9, and that's 9 pounds. Then look at all these other components here. 1/8 is pretty close to 0. 4/10 is close to 5/10, which is a half. 7/8 is actually close to 1, which is another whole number, and 6/10 is pretty close to a half. So I pick up 2 extra half pounds and 1 more whole pound, which means I'm adding 2 as my adjustment to get roughly 11 pounds. Now, again, that's because we're answering the question about how many pounds do we have. If we needed to find the exact value, we would actually need a common denominator as we were going. So just read the question carefully. If it's just saying roughly estimate, do your best to estimate. I know as you're going forward, sometimes these are a little challenging as you get used to it. But when you have numbers like 11/12, you're pretty darn close to 12/12, which would be 1. If you have numbers that are like 2 over 5 is pretty darn close to 2 over 4, which is about 1/2. So again, you may be up or down on the rounding on your estimate, could be higher or lower, but the goal is to kind of get there quickly. Okay, so here's another example from grade 5 that says about where would we be estimating? And that wraps up it looks like our piece. So in the homework, you will see some that say sort the fraction cards into the ovals by kind of saying which of these numbers should be about 0, which are about a half, and which are about 1. That's the estimating part. And it is really helpful to try to get yourself close to where you can kind of say, okay, I get the idea. I know kind of what are some ballparks for myself. And as an example, like I'll just kind of jump to one here. This one says 4 over 7. So seven's not a quick one that you can take half of because it would be kind of a decimal number or a fraction itself. So then think about 4 and compare it to like 4 over 8 because you can double the numerator very quickly. So 4 over 8 is really close to 4 over 7, and 4 over 8 is 1/2. Okay. So when you think about things like that, if you had something like 7 over 12, you might say 12, well, I could think of 12 and half of 12 is 6. So if you have that, that's really close. You could say, okay, these are really close together. So again, if I was estimating, trying to do it quickly, I might use 1/2 instead of 7/12. All right. All right. So again, apologies for the 2 videos for this one, and we'll try to avoid that in the future. I hope the computer doesn't have a glitch again. Anyway, I appreciate your patience. Off you go.